So where we finished on Thursday was 21 and 20. Addition, subtraction. Because with addition, subtraction, if the denominators are the same, we add or subtract the numerators. Now, if the denominators are different, we have to get them to be the same so that we can add or subtract. And whenever we're trying to get them to be the same, we need to make sure to factor them first. Factor them as far as they possibly can go so we can get them to be the same from there. Now, between these two, x plus 7 is as simplified as it gets. There's no greatest common factor between x and 7, and that is simplified. Now, we do need to factor the other denominator. All right. All right, guys. X squared plus 5x minus 14. We need to factor it. So we want to have x and x.
X plus 3 and x minus 3. Or x plus 3 x minus 7.
You're welcome.
Or x plus 7 and x minus 32.
Oh, since the third term is negative, our signs would be opposite. Factors of x squared are x and x. Factors of 14 and 1 and 14, or 2 and 7.
I see that we're on number 22 now.
All you guys want to hear that we did the review. Daniel Skin. Yeah.
So it works out to be x plus 7 and x minus 2. Because we can check and make sure we do get a middle term of 5x.
I said 3. I meant 2.
X times negative 2 is negative 2x. 7 times x plus 7x. Giving us the positive 5x that we wanted. Now we need to get the denominators to be the same. What does the left denominator have that the right denominator does not? X minus 2, so we have to multiply on top and bottom by x minus 2. Is there anything else that the left one has that the right one does not? No. Is there anything that the right denominator has that the left one does not? Nope. So for this here, we only have to multiply the one on the left. Or sorry, the one on the right by x minus 2 on top and bottom. We don't have to do anything to the one on the left. So the one on the left is going to say x squared minus 5. Because this whole process that we're doing here is to get the denominators to be the same. Because we multiply the denominators x plus 7 by x minus 2, we get x plus 7 times x minus 2. We're not going to distribute that out. We're just trying to get them to be the same. Now the numerator, we do have to distribute this. Because with our numerator, we will have to combine like terms, so we have to distribute this out. Now our x times x is x squared. X times negative 2 is negative 2x. 3 times x is plus 3x. And 3 times negative 2 is negative 6. Now the one on the left stays the same. It's x squared minus 5 over x plus 7 times x minus 2. The numerator on the right, we do have some like terms we'll need to combine. Our negative 2x plus 3x would be plus x minus 6. Questions on how we got to this point here? Now, since the denominators are the same, x plus 7 and x minus 2, we can subtract the numerators. Now, since we're subtracting more than one term on top, it's going to be good to put both numerators in parentheses, because we have to make sure that we distribute the negative correctly. Now, the x squared minus 5, since it doesn't have a number or sign in front of it, we can just drop the parentheses. It's going to stay x squared minus 5. Since we're minusing the other, that negative in front of our other set of parentheses has to be applied to everything inside. So our positive x squared is now negative x squared. Our positive x is now negative x. And our negative 6 is now positive 6. And last but not least, we can combine like terms. The first set of like terms we can combine is our x squared and negative x squared, which would be 0. They would cancel out. They're gone. Our next term is negative x. Well, it is the only x term, so it's just negative x. Negative 5 plus 6 is plus 1. And that is our final answer, because we could factor the negative out, giving us negative x minus 1. I will take either one of these, but either way, it's still the right answer. There's nothing that simplifies on top and bottom. Questions on this here? We ready for the next one? We're not going to worry about 23 because there's not going to be one with 3 parts or as complicated as that there. So we're not going to worry about it at this point. Next thing we're going to do is find least common multiple for each problem, each set of expressions. We're going to look at 2. I'm going to look at 26 and 29. Those are the 2 we're going to look at. And with least common multiple, we need to factor it down as far as it possibly will go. 2x squared is as simplified as it gets. There is no factoring it because there's only one term. 4x plus 12 is our greatest common factor. 4. And if we factor it out, we get 4 times x plus 3. So we took out the greatest common factor. There's no more squares. That's as factored as it gets. Which means we can now look for the least common multiple. With least common multiple, especially with polynomials, I find it easier to look at the expressions first, our terms in parentheses. Well, the one on the right has an x plus 3 once, so we're going to need it at least once, yes? The only way that it would change is, well, if the other one had it twice, then we would need it twice. But the one on the left has x plus 3 once. The one on the right doesn't have it at all, so we only need it once. Now we're looking at least common multiple between 4 and 2x squared. Because 2 is going to be part of it. 4, it would be 4. Because we're looking for the first number we can turn both 2 and 4 into going up. And it actually works out to be 4. Because it can be equal to one of the two numbers. But we can look at this with multiples of 2. Because 2, 4, 6, 8, 10, 12, and going on. 4 is 4, 8, 12, 16, 20. Well, 4 is the first number we can turn both 2 and 4 into. Yeah. And there's 2 of these on the test, and that's it. Now, we've taken care of the 2. We've taken care of the 2 and 4. X plus 3. The only thing left is the x squared. Yes? Well, we need x squared. Even if it had been 2x squared and 4x, x squared, one of them has x squared, the other has x. So the least common multiple would be x squared.
That's it.
That's it.
Or what it was. Why was that so hard?
I don't know. This is,
I was sitting here all class trying to figure that out.
and again, this is not something it is something that most every year students have struggled with. But once you see it, it makes sense. Let's look at 29. Always look for greatest common factor first when factoring. Is there a greatest common factor between 4x squared and 16?
16, 4 and 4 makes 16.
4. Because 4 will go into both 4 and 16.
4
So I think you're thinking of least common multiple. Least common multiple would be 16. But before we start looking at it, we want to factor down. So greatest common factor would be the biggest number that will divide into every term. Least common multiple, we're going up. Now, x squared minus 4 factors nicely. Because what would that be?
X and x plus 4 and x minus 4. Or x plus 2 and x minus 4.
There we go.
You're right.
X squared minus 4 is a difference of perfect squares. Because if we have x squared and a number, we're looking at possible difference of perfect squares. X squared is x and x, 4 is 2 and 2. If we want to check for if it is a perfect square with our numbers, not variables, we can take the square root of it. So that's completely factored. If we look at our other set, 6x squared minus 24x plus 24, is there a greatest common factor? 2 is a common factor, but it wouldn't be. It is 6.
Good job. I told you to say.
No, you were saying 6 to the left.
I don't know. I was close.
You were working ahead.
So if we factor the 6 out of 6x squared minus 24x plus 24, we get 6 times x squared minus 4x plus 4. So we're just dividing each of our original terms by 6, and we put it out front.
X minus 2 squared.
Yes. Since the third term is positive, our signs are the same, match the sign of the middle term, negative and negative. Factors of x squared are x and x. And our factors of 4 are 2 and 2. Least common multiple. Again, I'm going to start off with our sets of parentheses. So the one on the left has an x plus 2, has it once. How many times does the one on the right have it? 0. So how many times do we need it?
0. Oh, why not say 0?
We need it once.
Once.
Because it showed up once, we need it once. Now the other expression on the left is x minus 2, and we have it once on the left. The right has it twice,
So we need it once.
so we need it twice. Because if it shows up twice in one of them, we need it twice. We take it from whichever one has the most. Since the one on the right had it twice, we take it twice.
And then we're gonna that other thing is gonna be 12.
The first, yep, the least common multiple between 4 and 6. The first number we can turn both of them into is 12. Because we can look for 8, 12, 16, 20.
Wait, why did we pick 12? Because it's the greatest common, or
No, because we can turn 4. That's the first number we can turn 4 and 12 or 4 and 16. See.
So least common multiple is going up. So it's either going to be equal to or bigger than the bigger of the two numbers. Greatest common factor is equal to the smaller of the two or less. And yes, I still find it odd that we call the one where we're actually increasing least common multiple and the one we're actually finding a smaller number greatest. I still find that kind of an oxymoron. But questions on least common multiple. Last thing we have is solving. Last thing we have to look at is solving. Now with solving, finding restrictions, because in all of 7.5 where we solved, we listed the restrictions. If you notice in 7.5.1, in the lesson we didn't have a single restriction. It did show up on the homework, but didn't list them out. 7.5.2, we started seeing the restrictions come into play. And for the test, unless it states in the instructions, be careful of restrictions, or talks about restrictions in the instructions, they're not going to show up. So there is a section where we're solving and the restrictions don't come into play. There is a set where the restrictions do, and it will say it in the instructions. So if it doesn't talk about the restrictions, they're not coming into play. Now, for this here, the first one I'm going to look at is 34. Because most of the others that we have so far, 31, 32, and 33, that setup doesn't show up. I do those. I do work those out in the full video, but we're going to focus on these here. Number 34. With solving, just like addition or subtraction, we do not factor the numerators. So 4x plus 1 and 12 are not factorable anyways, but even if they were, we're not going to factor them. Because if they did factor, we would have to unfactor them to be able to solve. It's just an additional step. But the denominators we do need to factor. Now x plus 1 does not have a greatest common factor. There is nothing to simplify, so it's just x plus 1. X squared minus 1 does factor. Now, there's not a greatest common factor to factor out of it, but it is a difference of perfect squares, which gives us x plus 1 and x minus 1. Now, if it had just been a greatest common factor of, say, x, we would factor it out and go from there. Now, this one here, I'm going to go on and just list our restrictions.
What if we don't give the restrictions? This is just like a hypothetical.
You would just lose the points attached to that.
Okay, but what if we don't get the restrictions right, or miss a restriction, and then we list a restriction and don't cross it?
It would just be a point or two, yeah. You wouldn't lose all points, but it would be a point or two. So for our restrictions, positive or negative 1. X cannot be positive 1 or negative 1. So if we get one of those two restrictions, we have to throw it out. It doesn't work. Now, what do we need to multiply the whole equation by?
X minus 1.
So x minus 1
And x plus 1.
and x plus 1.
Yeah.
Because we multiply by x plus 1 and x minus 1. The far left, the x plus 1 and x plus 1 would cancel. In the middle, the x plus 1 would cancel.
Hey, time out. You're going too fast.
And the x minus 1s would
Right
cancel.
off the step. Wait, x minus 1 plus, yeah.
So we're multiplying the whole thing by x minus 1 and x plus 1
Okay.
in every single spot. The far left expression,
Cancel on the
x plus 1 and x plus 1. Yes. So we apply it to everything. Now, since the 3 does not have a denominator at the bottom of that fraction, nothing's going to reduce. So what we're left with is our 4x plus 1 times our x minus 1 is equal to 12. Now, since everything we multiplied the 12 by simplified out with the denominator, it's just 12. Plus 3 times,
Wait, did you put parentheses around that x, or 4x plus 1?
yes, because we're multiplying the 4x and 1 by our x minus 1, the whole thing.
Okay, so what if we didn't put parentheses? What would that would it come out to something different?
Well, it's just making sure that we remember to We multiply here.
Oh, okay.
Now we're doing 4x times x, which is 4x squared. 4x times negative 1 is negative 4x. And we're going to do the same thing with our plus 1. 1 times x would be plus x. 1 times negative 1 is negative 1. 12 plus. Here we're going to distribute the x. So we're going to wait to multiply through by the 3. So we're going to do 3 and then have our multiplication out. X times x is x squared. X times negative 1 is negative x. 1 times x is plus x.
Because it's easier.
Because if we did multiply it through, we'd have to only multiply it with 1. Either the x plus 1 or x minus 1. We couldn't do both.
Because it would come up to something different. It wouldn't have the square.
Well, if you did, you'd have an extra factor of 3 if you multiplied it by both instead of just 1. So it's easier to just wait. Now on the left-hand side, we're going to combine like terms. Negative 4x plus x is negative 3x. So the left-hand side is 4x squared minus 3x minus 1. The right side, so we'll still have 12 plus 3 times. Our negative x and positive x is 0, telling us that we have x squared minus 1. And that makes sense because where did we get the x plus 1 and x minus 1 from?
There.
X squared minus 1 because we factored it and it went back. Now before we can start getting everything on the same side, we do need to distribute this 3 now. 3 times x squared is 3x squared. And 3 times our 1 is negative 3.
I didn't know how to say it like that.
Yeah, you did.
Now we do have like terms now between 12 and negative 3. So our 12 minus 3 gives us, nice. Do we have any like terms on either side of the equal sign? All right, guys. Now, since we have an x squared term, we need to get this equation equal to 0.
We got 3x to 4x.
So we can subtract 3x squared from both sides. 4x squared minus 3x squared is x squared. Minus 3x minus 1 is equal to 9. At this point here, we can subtract 9 from both sides. 12 minus 3.
9. Yeah, that works.
Combining like terms.
What?
Questions on how we got to this point here? Any other questions on how we got to this point here? So this is the step before we get there. Now there's 2 ways we can go from here. One of them is to factor it. We can factor this down and go from there, or we can graph it. So in the graphing calculator, the first thing we would do is hit y equals x squared minus 3x minus 10. And hit graph. And we're looking for what x values make the y value 0. So second graph gives us a table.
Negative 2 and 5. X equals. Negative 2. Negative 5. Not negative 5. Oh, 5, sorry.
Negative 2 and 5. And that's it. Now one of the ways we know that with the quadratic, if it will give us both, is if the number in front of x squared is 1. If there's not a number in front of x squared and there's no greatest common factor, the number we can pull out, we can graph it and it'll give us both. There's only one on the test that we actually have to factor. The rest of them will graph. Questions on this here? Let's look at 35. Now 35, the restrictions won't come into play, but I'll go on and list them.
Why won't they come into play?
Mainly because I know the solution. And this would be one of the ones that's listed on just solve. It won't say the restrictions or talk about the restrictions in the instructions. But the spots where the restrictions would be our 3x. To solve for it, we would divide by 3. Telling us that if x is 0, the denominators would be 0, so x cannot be 0. Now, we need to see what we need to multiply everything by to solve.
6 and 3x. Oh my.
And if we do this here, 3x and 3x would cancel. Here, the 6 and 6 would cancel. And lastly, the 3x and what that leaves us with is 2 times 6, which is 12. Plus 1 times 3x is, and 4 times 6 is. Do we have an x squared term? Is there an x squared term in this here? No. Solve for x. Get x by itself. So the first thing we can do is telling us 3x is equal to 4. That's it. There's actually only one solution for this here, and it's 4. That's it. Questions on 35? We'll look at 38 next. That should be negative. And again, with any of these solving, even if the numerators are factorable, we're not going to factor them. Yes?
So it's funny how I said the exact same thing.
Now, before we list restrictions, because we are going to need to list them on this one here, we do need to make sure that all the denominators are factored. X minus 2 is not factorable because there is no greatest common factor, and there is no x squared term. X squared plus x minus 6. Since the 6 is negative, our signs would be opposite. Factors of x squared are x and x. And we're going to have x plus 3 and x minus 2. And you can go through and check it if we want, because our x times negative 2 would be negative 2x. 3 times x is plus 3x. And our 3x minus 2x would give us our positive 1x. Restrictions are x plus 3 and x minus 2 are the two places where we could have a denominator of 0. Now with our x plus 3 minus 3 telling us that if x is negative 3, we would have a denominator of 0, so x cannot be negative 3. And for x minus 2, we would add 2, telling us that if x is 2, the denominator would be 0, so x cannot be 2. So if we get 2 or negative 3, it'd be a restriction, and we would throw that term out. Now, what are we going to multiply everything by? X minus 2 and x plus 3. I did have a question earlier today if we needed x minus 2 twice, because it does show up twice. But I would always start out with one of each, multiply through, and simplify and go from there. Because if we look at the x minus 2 on the far left, x minus 2 and x minus 2 would cancel. Well, the x plus 3 and x plus 3 would also cancel. Our 2 term in the middle does not have a denominator, does not have a bottom of the fraction listed, so nothing simplifies. And on our far right, the x minus 2 and x minus 2 would cancel. So do we have anything left? So we have x minus 3 on top, yes? So we don't have to worry about simplifying it. We're just worried about the bottoms of the fractions. So every denominator, every bottom of the fraction simplified out. So we don't have to add anything else. If something didn't, then we can multiply through by it to get it to cancel also. And what that leaves us with is, well, -5, because everything canceled out on top and bottom, leaving us with just -5. The middle is 2 times x minus 2 times x plus 3 plus x minus 3 times x plus 3. Now, the first thing we can multiply is our x minus 2 and x plus 3. We will have to leave the parentheses because the number 2, that 2 is going to multiply by it, yes? What would our x minus 2 times x plus 3 multiply to give us?
X squared plus x minus 6.
Yes. And that seems like it's weird to pull that back out, but x minus 2 and x plus 3 came from where? Factors of x squared plus x minus 6. Now, if you don't notice that, that's perfectly fine. You want to multiply back out. Because if we multiply that out, and I'll go on and write it here, x squared times x, or x times x would be x squared. X times 3 would be plus 3x. Negative 2 times x would be negative 2x. And negative 2 times 3 would be negative 6. Which does end up giving us x squared plus x minus 6. Now, if you're able to notice that x minus 2 and x plus 3 came from our x squared plus x minus 6, you could have just replaced it at this point here, because it'll get us back to the same place. Plus, we don't necessarily need the parentheses when we multiply the x minus 3 and x plus 3 together, but putting them is not wrong. We'll do the same thing. X times x is x squared. X times 3 is plus 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is?
So x squared plus 9.
X squared, almost? Minus 9, because our positive 3x and negative 3x become
What's that middle row? What is that?
here.
No. What does that say?
X squared plus 3x minus 3x minus 9. So we're doing our x plus 3 times x minus 3. And the 3x and negative 3x become 0, leaving us with x squared minus 9. Now at this point here, we can distribute the 2. 2 times x squared is 2x squared. 2 times our x is plus 2x, and 2 times negative 6 is negative 12. Plus x squared minus 9. We don't need the parentheses around the x squared minus 9 because there's not a number in front of it, and the sign's plus, so nothing changes there. Now, before we start getting this equal to 0, we're going to combine like terms. 2x squared plus x squared is 3x squared. 2x doesn't have any like terms, so it's plus 2x. And our negative 12 minus 9 is negative 21. Questions on how we got to this point here? Now we do have an x squared term, yes? So we have to get this equal to 0.
Plus 1.
So we're going to add 5. Telling us 0 is equal to 3x squared plus 2x minus 16. So again, we can still graph this. 3x squared plus 2x minus 16.
It's going to have a decimal.
One of them is going to be fractional, yes. 3x squared plus 2x minus 16.
What would we do? You would use the formula.
We're going to have to factor. Because if we look at this here, second graph, it does tell us one of the solutions is 2. If one of them is an integer, non-decimal number, it means the other is rational, is a fraction. It is factorable. All the ones on the test are going to be factorable. So the one that does not give it to us by graphing, we can factor it with 2 sets of parentheses. We don't have to use the quadratic formula. Since our third term is negative, our signs are opposite. Factors of 3x squared are x and x, 3 and 1, so 3x and x. And again, at this point, I would plug it in. Just pick a spot for 3. Factors of 16, 1 and 16, 2 and 8, 4 and 4, 2 and 8. And I can check this here to make sure. 3x times negative 2 is negative 6x. 8 times x is plus 8x, giving us a positive 2x, which is the middle term we wanted. Questions on how we got to this point here? Because we're one main step away from solving, finishing.
A little bit longer to do that. Okay, when it has numbers in front of the heads.
Yep. 2 things multiplied together to equal 0. One of these expressions must be 0. I'm going to do the x minus 2 first, because all we have to do is add 2 to both sides, telling us x is equal to 2. 3x plus 8, we would subtract 8, telling us 3x is equal to negative 8. Divide by 3, telling us x is equal to negative 8/3. Questions on this here?
So what did it say on the graph? What did it say on the graph, Alan?
So we'll see here in a second. Is either one of these a restriction? Because it couldn't be 2 or negative 3, so 2 is not possible, because it would give us a denominator of 0. Since it's one of our restrictions, we just cross it out, which means negative 8/3 is the correct answer. Now, if we look at the graph,
We could have just turned that decimal.
so it is between, because negative 8/3 is, goes 6, 2 and 2/3, which does show up here. If we wanted to check a value, second trace, to calculate, the top one is value, yes? And I could say negative 8/3, because I'm giving it an x value, it's going to tell me the y. Enter. And the y value is 0. So it is our other solution. And it ends up being negative 8/3 is the only solution for this here. Questions? Yeah, but that's it. Since the other one's a restriction, we just throw it out. So negative 8/3 is the only solution for this here. Questions on any of this here? So that is really the end of the review sheet. And we're also, I believe, out of time. But I would go back through and look at some of the others. And if you missed the first Thursday, go back through, watch the video, because there is part 1, but there is also the full review video. So if there's some of these, especially with solving, that you want to see a few more done, look at the full video. I do have them all solved. I do all of them.